Okay. All right, so there is a whole new world out there for you kids. Imaginary numbers seems crazy. Everything you've done up until this point have been real numbers. If you were asked to take the square root of a negative, you'd say no solutions, does not exist. Well, the truth is there are solutions. They're just imaginary, okay? And believe it or not, this has its place a lot in like electrical engineering. So if anyone was ever going to become an electrical engineer, they actually use imaginary numbers in that world. So we're just going to teach you the basics. The definition, first of all, imaginary numbers and complex numbers are the same thing. So if you see write your answer as a complex number or write your imaginary answers, means really the same thing. So the definition of this, of an imaginary number is this. I, which we will use a lot, means the square root of negative 1. Okay? So when it comes time to simplifying something like negative 9, the square root of negative 9, the square root of 9 is still 3, but because there's that negative there, it's going to be 3i. The square root of negative 100 is 10i. Okay? So those were perfect square numbers. Now take something like 32. There is a negative there. But go back to what's the biggest perfect square that goes into 32? 16. So when you break this up, we're going to break it up into root, keep the negative with the perfect square. Negative 16 times root 2. Root negative 16 times root 2. And then the square root of negative 16 is 4i, right? 4i root 2 would be your final answer there. Kaylee M., how can we break down negative 18? What times what? 9 times 2 gives me 18. I need negative 18. Negative 9, right. Keep the negative with the perfect square. Micah? Okay, that's okay. I like for you to think it out. So that gives us 3i root 2 for D. Okay, so there's this whole new world out there of imaginary numbers. Now, when we solve quadratics, okay, same thing's going to happen to us. We now may have imaginary solutions. Okay, so if I were to solve this, now this quadratic, do you see how it does not have an x term? If it doesn't have an x term, you can get the x all by itself. So I'm going to subtract 8 over. I'm going to divide by 5, so x squared is going to equal negative 4. And I'm going to take the square root of both sides. Couple things here. Anytime you take the square root of both sides, you have to remember your plus or minus. And the square root of negative 4 is what, Grace? 2i. So you have two solutions. Plus or minus 2i. Two solutions, they're just not real. They're imaginary. Does this make sense? Okay, I'm going to skip B and C for the sake of time. We do the same thing with imaginary numbers on exercise 3 that we would do with variables. You can combine like terms. So 5i, or in this case that's a multiply. We multiply them, add them, subtract them the same way we would do if they were x's. Okay? 5i times 6i is 30i squared. Okay? But there's something else I have to teach you about i's, a critical piece. And this will eventually be on a flashcard as well. I is just I. You can have an I in your final answer. That's fine. You cannot have I to any power in your final answer. So if you ever have I squared, you tell me. If I take an I is the same thing as the square root of negative 1, right? That's the square root of negative 1. So if I take that and square it, what does that give you? Say that one more time. No, I am going to make it an I squared. But in this, like I times I is I squared, but now the I squared is getting replaced with a negative 1. So what's 30 times negative 1? Did that clear it up? Good. So that's option 3. I'm going to keep going with this cycle. I cubed. Now, don't write this part down, but isn't I cubed the same thing as I squared times I? And if I squared is negative 1, what's negative 1 times I? Negative I. Right? Negative 1 times I is the same thing as negative I. So an I to the third power would be replaced with negative I. I to the fourth. Correct me if I'm wrong, but isn't I to the fourth the same thing as I squared times I squared? What's negative 1 times negative 1? 1. So if you see an I to the fourth, it's just 1. Now, don't write down I to the fifth. Just watch what I'm going to do here. Isn't I to the fifth the same thing as I to the fourth times I? And what is I to the fourth? 1. What's 1 times I? Just I. So don't write this down. I to the fifth is just I. The cycle is just going to now continue. So if this is I to the fourth, this is I to the fifth, I to the sixth, I to the seventh, I to the eighth, I to the ninth, I to the 10th, I to the 11th, I to the 12th. Yes? Okay? So it's a cycle of 4. So anything that's a perfect multiple of 4 is going to be 1. So let's jump down to exercise 5. This is what I'm going to be getting at down here. Can you read that? That says I to the 38th. Okay? We want to split that up into something that's a multiple of 4. So what is the first number under 38 that's a multiple of 4? First number under 38. I hear someone whispering it. 36. So I to the 36 times I to the what would be a replacement for I to the 38? Think exponent rules. 2. And the reason I like that I to the 36, it's a multiple of 4, so it's just 1. So I can just cross it out. It's 1 times I squared. And what do you guys now know that I squared equals? Negative 1. Okay? Does this make sense? I to the 21st. What's the first number under 21 that's a multiple of 4? 20. So I'm going to split this up into I to the 20th times I to the, think exponent rules, first. I can cross out the I to the 20th, so my answer is just I to the first, which is just I. I to the 83rd. What's the first number under 83 that's a multiple of 4? 80. So I to the 80th times I to the 3rd. The 80th is going to cancel. And what do we learn I to the 3rd was the same as? Negative I is your final answer. So do you see how your final answer, there's never allowed to be an exponent on I? Because if there is, it can be simplified. Do we follow? Okay? And how about I to the 40th? Right, it's just 1. Because 40 is already a multiple of 4. So this is just 1. You may. Any questions on that? Yeah, Isaiah.
So it's always going to be I.
Right. And it really ends up being whatever the remainder is. Do you see that? So it's kind of like whatever the remainder is the rule that you then have to use from that point forward. Because your remainder will always be either a remainder of none, right? Or a remainder of 2, right? Which will make, so you get that. Okay. So exercise 6 asks you to find the equivalent. Okay? Now here's the issue. If those were just x's, we wouldn't be able to combine like terms because we have an x to the 16th power, an x to the 23rd, and an x to the 36, or is that a 26? 26. So I can't do it if they're x's, but because they're i's, I can reduce I to the 16th. What is that the same as? Just 1, right? Because 16 is a multiple of 4, I to the 16th is just 1. What's 5 times 1? Okay, so that first term is just 5. Think about I to the 23rd for a second. What's the first multiple of 4 underneath 23? So that's I to the 20th times I to the 3rd. The I to the 20th is going to cancel. Oops. I to the 3rd is the same as negative I. So that's a 3 times the negative I. Do we follow? 3 times negative I is negative 3I. That's our second term. And then I to the 26. How do we break down I to the 26? Give it a stab, Maddie. Right, I to the 24th times I to the 2nd. The I to the 24th cancels, and then Maddie, what's I squared the same as? Negative 1. So this all ends up being 5 minus 3I minus 1. And so 5 minus 1 can combine now to 4. So we get 4 minus 3I, which is option 2. Okay? Go back up to the top, unless I said it on the back. I did not. On the back. Complex number. A plus BI. That's the format. Your constant, whatever the A value goes first, and then your BI term comes second. So in this case, 4 is our A, and our BI, our B is negative 3. Does that make sense? Any questions on that? Exercise 1 here, just sums and differences. We're just going to do part D. If you're asked to subtract, it's the same as operations would be with x's. So negative 3 plus 5i. And if you're subtracting a binomial, we need to distribute the negative, yes? So minus negative 8 turns to plus 8, minus 2i, and then combine like terms. Negative 3 plus 8 is 5, and then 5i minus 2i is plus 3i, and there's your A plus BI format. Okay, exercise 2 is the same. It's just a sum, which is just add. We're going to jump to exercise 3. Products. Multiplying. Let's do, I don't know, B. Okay? Product, you distribute, right? Double distribute, FOIL, whatever you want to call this. What's negative 2 times 3? Negative 6. What's negative 2 times negative 2i? 4i, right? Plus 4i. Move on to your 6i. What's 6i times 3? 18i. And what's 6i times negative 2i? Negative 12i squared. Very good. This is something you're going to have to do a lot. If we got an x squared term, we would just leave that, right? And we would combine our like terms, and that we can do. So it's negative 6 plus 22i, but we cannot leave an I squared. The I squared is the same as what? Negative 1. That's the one we're going to use most often. So what is negative 12 times negative 1? Plus 12. It's going to sort of just flip the sign of that term. And now I can combine negative 6 plus 12 is 6 plus 22i, and there's my A plus BI format. Any questions on that? Let's go down to exercise 6 as our last one. No, I don't want to do that one. Let's do exercise 5. this we're just gonna simplify out. So is everyone clear that we're gonna FOIL the first part and then distribute the 4i and then combine like terms and simplify from there? Does everyone see the structure of that without doing it? Okay, so it's just that's just algebra 1. That's just a more complicated simplifying. I do just want to talk about purely real number. A purely real number is something that when I have the a plus bi format, b is going to be 0i. You're going to have no i's, and so it would just end up being a. Does that make sense? So you'd sort of have to guess and check on this one. You'd have to FOIL all these out and see which one the I terms cancel. Can you look quickly? Can anyone tell me what it's going to be? And it has to do with the outer and the inner canceling. Which one of these products are going to have an outer and inner cancel because they are conjugates? Number 3. 5 plus 2i, 5 minus 2i. You're going to get 25. When you start FOILing, you'll get 25. You're going to get minus 10i plus 10i. Those are going to cancel, right? And your last term is going to be negative 4i squared. But the I squared is going to turn that to a plus 4. Very good idea. Okay, so if you know that little trick on conjugates, you can get that really without going through every single FOIL. Homework's a little bit longer tonight, but you're going to find a lot easier and straightforward and simple. So it's stable. Have a good day.